find the 10th term in the sequence. So 2 parts here. Work out the nth term of that sequence and find the 10th term in the sequence. Probably worth 1 mark for the 10th term in the sequence. And the nth term's around, let's say, 2 to 3 marks, but we'll go with 2 marks on this top one. So let's put our sequence down to give some room. So 1, 5, 15, 31, 53, and ... First step is to try and spot patterns. So let's see what it's going up in. So 1 to 5 is +4. 5 to 15 is +10. 15 to 31, that's +16. 31 to 53, that's what's that, 22? So first difference doesn't match. So we've got to go again, we've got to do the second difference. So 4 to 10 is +6. 10 to 16 is +6. 16 to 22 is +6. And that's great because the second difference matches, which means this is a quadratic sequence. It's going to have an n squared in it somewhere. So we're going to use the algebraic approach on this one. So we're going to just remember 2a's equals this +6 at the bottom there. You need to remember 3a plus b equals that first difference there. And you need to remember a plus b plus c equals the first term of the sequence. Once you have these 3 equations, we're going to start with our equation 1 and work our way up to equation 3. So we'll start with equation 1. 2a equals 6. Therefore, if we divide both sides by 2, you'll get a equals 3. So that's one of them that we'll need. And then we'll move on to equation 2, which is 3a, i.e. 3 times 3, because a is 3 from the first one, plus b equals 4. That's 9 plus b equals 4. Take 9 from both sides, b equals -5. And finally, equation 3, a plus b plus c. So we've got 3 plus -5 plus c equals 1. So that's -2 plus c equals 1. Add 2 to both sides, c equals 3. Now we can string the full equation together. So all quadratics will look like this: an squared plus bn plus c. And we know a is 3, so it's 3n squared. B is -5, so -5n, and then c is 3. And that should be our answer, but we might as well check it. So here's what you do to check this. Let's check the 5th term, because 1, 2, 3, 4, 5. Let's check the 5th term. So you put a 5 in there. We might as well do this manually. So we'll put a 5 in there. So we'll say, well, let's just put check. This is just a quick check. So we've got 3 times 5 squared minus 5 times 5 plus 3. So 5 squared is 25 times 3. That's 75. Take 5 times 5 is 25 plus 3. 75 take 75 take 25 is 50 plus 3 is indeed 53. It's highly unlikely you're going to fluke that. This has to be right. Unless you did fluke it. But it's very highly unlikely. 99.9% chance you've got this right now. You can't really fluke that. And if you wanted to try another term of the sequence, then you definitely know it's right. So, 2 marks in the bag there. And you just need to find the 10th term now. Now you just need to sub that in for the 10th term. So final answer for that first one is this thing down here. Should we do it in a different colour? We'll box it off in red. That's the final answer there. And the 10th term, you just got to sub in 10 this time. So we can say 3 times 10 squared minus 5 times 10 plus 3. 10 squared is 100 times 3, which is 300. 300 take 5 times 10, which is 50, plus 3. 300 take 50 is 250, plus 3 is 253. And we'll put that in the red box as well, because that's the answer for part B. That's the answer for part A, and that's the answer for part B. Let's say you didn't know how to do the nth term. You can still get the 1 mark, by the way, if this comes up in your GCSE calculator one anyway, maybe, or even non-calculator. Because you've been given, what, 5 terms there, you just need another 1, 2, 3, 4, 5. Just continue the pattern. Add 28, add 34. Just keep adding until you get to the 10th term. But then this could have easily said the 100th term, and then you'd be in trouble, because you'd need the nth term, really. Because, I don't know about you, but adding numbers 100 times, it's going to take a while, right? But thank you so much for watching, and don't forget to follow for more number tips.